Okay, we've discussed the principle of angular impulse and momentum. Let us look at a quick example here. We have two balls of negligible size and mass of 10 kilograms, and they're both attached to the end of a rod whose mass may be neglected. If the rod is subjected to a torque, so we know the moment as a function of time, where t is in seconds, of course, we're asked to determine the speed of each ball when t is equal to 3 seconds. Each ball has a speed v is equal to 2 meters per second when the time is equal to 0. So we can clearly see here that we're dealing with moments. We have a rotation, we're given time, velocity, and mass. So we're clearly using angular impulse and momentum here. So I'll give you a couple of minutes. You can try to solve this problem. It's fairly straightforward. You just have to plug in your numbers and calculate. And whenever you're ready, just continue the video. So let us write down what we know. We know the radius, which is 0.5 meters, the mass of the two balls, 10 kilograms. The mass of the rod is negligible, so we can assume it to be equal to 0. The velocity of the two balls is 2 meters per second at t equals to 0. And we have an expression for the moment as a function of time, t squared plus 2 Newton meter. So what is the velocity of the two balls at t equals to 3 seconds? Again, we have mass, velocity, radius, moment. We can see that we're dealing with a rotation about the fixed axis, so angular momentum seems to be appropriate here. Let us draw the free body diagram. Taking the two balls and the rod as a single system, we want to reduce the number of unknowns to the minimum here. So we have the weight of the two balls, mbg and mbg, and the moment applied at the axis, which is t squared plus 2. So just looking at the forces and the moments here, we can see that the weight does no moment whatsoever about the center of rotation, since the weight is parallel to the axis. So our only contributing component is the moment t squared plus 2. So we can write down the angular momentum equation, summation of hz1 plus summation of moment dt is equal to summation hz2. And the reason why we're using the summation here is because we're dealing with a system, right? We have the two balls and the rod. So we can expand that, mb1 v1r, which is the angular momentum of ball 1, plus mb1 v1r, which is the angular momentum of the second ball, plus the integral from 0 to 3 of that expression we have, t squared plus 2 dt is equal to 2 times mbr v2. And we only have one unknown here, which is v2, the velocity of the two balls at state 2. So one equation with one unknown, we can easily solve for it. All we have to do is evaluate the integral, t squared plus 2 dt, which gives us t cubed over 3 plus 2t from 0 to 3. And we can simply calculate v2 and get v2 is equal to 3.5 meters per second. Very straightforward example, which uses the principle of angular impulse and momentum.